In this example, I want to demonstrate the net present value function in both Excel and on a financial calculator. And for this example, I'm going to use Kendall and Brenda. I believe that Kendall wrote a book. He was mentioning it in class the other day. And let's say that he needs some money right away. And what he'd like to do is borrow some money from Brenda today, and he'll pay her back with his book royalties from the future. Now, he doesn't know what his book royalties will actually be, so I'm just going to estimate some numbers. Let's say he thinks he'll get $10,000 in royalties a year from now, $5,000 in 2 years, and $3,000 in 3 years, and at that point, he doesn't think he'll sell any more copies, and he doesn't want to have a loan outstanding with Brenda anymore at that point anyway. So he goes to Brenda and asks for a loan. Brenda currently is investing her money in the stock market, and if she lent Kendall money, she'd take it out of the stock market, and let's say she's been earning a 12% rate of return with her money, and she thinks Kendall's investing in Kendall, giving him a loan equal to his royalties is, let's go ahead and say, about the same risk as the stock market. So basically, I'm saying that Brenda has a required rate of return of 12%. So she's willing to lend Kendall money, but she wants to earn a 12% required rate of return. This is all he is willing to pay her in the future. So the question is, how much should Brenda lend Kendall today if this is all he's willing to pay in the future, and she wants to earn an annual rate of return of 12%? Well, to do that, what we could do, or to calculate the answer to the question, how much should Brenda lend Kendall, what we could do is discount each of these 3 years separately. I could pull this one back 1 year, this one 2, and this one 3 years, all at the 12% rate of return. So just for fun, I'm going to go ahead and do that. So I will use the present value function. The rate is this 12%. I'm going to make it an absolute reference because when I copy it down to C4 and C5, I still want to refer to the 12% rate. And the way that I change that from absolute to relative references, I'm just pressing F4. And then the number of time periods, this 10,000, he would pay her in only a year, so we only need to pull it back 1 year. And then there's no payment, so I'm just skipping that. Or I could put a 0. And then the future value is that 10,000. I like my answer to be positive, so I'm going to input a negative future value. Giving it a quick once-over to make sure I didn't mess up anything. I usually forget to make things absolute when I shouldn't. And then I'm just going to double check it again to make sure it's referring to the right cells. So to Brenda, the 10,000 in 1 year would be worth only $89.28 to her today. The 3,000 in 3 years would be only worth $21.35 to her today. So the total value of the sums he's willing to pay her in present value terms is $15,050. So this is the amount she would be willing to lend to Kendall. And she would earn a 12% rate of return if he did indeed pay her these values. Now this is actually pretty easy to do in Excel, but there's a slightly quicker way to do it, and it's called the net present value function, or NPV. So with the NPV function, you just highlight your rate, a comma, highlight all your non-zero cash flows, all the cash flows you want discounted. Well, I want all 3 of those discounted. So it'll take the first one, pull it back 1 year, not because I've highlighted the one over here, but just because it's the very first one in the list. And then the second one will pull back 2 years, the third 3 years. So there's our $15,500 $49.88. And I shall record another video showing how to find this on a financial calculator.